Good afternoon, everyone. We're re-looking at a pattern change that ranks among the most significant I've seen in several years. Arctic air, multiple storm systems, the potential for major snowfall from the Carolinas through New England. Today, I want to put this in context with historical events many of you remember. This video runs about 15 minutes. I'll compare this setup to notable past storms. The blizzard of '96, the January 216 event. What is similar, what is different? Then, we'll examine the current model data in detail. Finally, specific timing and impacts for each region. Let me start with the atmospheric setup and why this matters. The 500 millibar pattern is the key. That's the mid-level of the atmosphere, about 18,000 feet up. At that level, the flow of air determines where storm systems develop and how they move. Right now, we have what's called an omega block setting up. If you look at the upper air charts, you can see it. High pressure over the west, low pressure over the east, high pressure over the Atlantic. It forms the shape of the Greek letter omega. This pattern is notorious for persistence. Once it locks in, it can last for weeks. We saw this pattern in February 2010. That was the Snowmageddon winter for the mid-Atlantic. We saw it again in January 2015. That was the blizzard of 2015 for New England. Both times, the omega block stayed in place for 2 to 3 weeks. The current pattern has that same structure developing, and the ensemble models, which run multiple versions of the forecast, show it persisting through at least January 30th. That is 20 days from now. Let us compare this to specific historical events. January 2016, the blizzard of 2016 for the mid-Atlantic. The setup was similar. Arctic air in place, coastal storm develops, rapid intensification as it moves up the coast. That storm dropped 20 to 30 inches of snow from Virginia through Maryland. New York City got about 2 feet. Parts of Pennsylvania saw 36 inches. The current setup has similarities. Cold air is colder, actually. The 2016 event had temperatures in the 20s and low 30s. We are looking at temperatures in the teens and low 20s this time. The difference is moisture. The 2016 storm had exceptional moisture from the Atlantic. Dew points were in the upper 20s, near 30 degrees. That's extremely high for a snowstorm. More moisture equals heavier snowfall rates. The current setup shows dew points in the low to mid-20s. Still sufficient for heavy snow, but not quite as extreme as 2016. If I had to rate this against the 2016 event on a scale of 1 to 5, with 5 being 2016, I'd put the current setup at a 4. Maybe a 4.5, depending on how the 18th, 19th storm tracks. February 2003, the President's Day storm, that one hit the mid-Atlantic and Northeast hard. It was actually 2 storms that merged. The first came from the Ohio Valley. The second developed on the coast. They phased together, creating a monster storm. Many of you remember that one. It shut down major cities for days. Snowfall totals range from 15 to 30 inches across a wide area. The current pattern doesn't show that phasing dynamic. Our storms are more straightforward, coastal lows moving up the eastern seaboard. That actually makes them more predictable. Phasing events are notoriously difficult to forecast because the timing has to be perfect. So while we might see significant snowfall, we're probably not looking at a phasing scenario like February 2003. January 1996, the blizzard of '96. This is the one many of you reference. For good reason, it was a historic event. The storm dropped record snowfall across the eastern United States. Philadelphia saw 30 inches, New York City 20 inches, parts of West Virginia and Pennsylvania saw 40 inches or more. 154 people died in that storm, most from heart attacks while shoveling snow, others from exposure, carbon monoxide poisoning from generators, house fires from space heaters. That storm had several factors working together. Extremely cold air, abundant moisture, slow movement. It sat over the mid-Atlantic for nearly 24 hours, just dumping snow. The current setup is different in one key way: movement speed. The models show our storms moving faster. The 18th, 19th system moves up the coast in about 12 to 18 hours. That limits total accumulation compared to a slow-moving system, but the wind could be worse. The January '96 storm had moderate winds. The current setup shows very strong winds, 40 to 60 miles per hour along the coast. That creates blizzard conditions even with lower snowfall totals. On the scale of historical storms, I'd place this pattern as potentially similar to January 2005 or February 2010. Significant, disruptive, memorable, but probably not at the level of January '96, unless something changes, and that is always possible. Now let us look at the current model data in detail. The GFS model 12Z run from this morning, that's the noon model run in UTC time. This run shows the pattern evolution clearly. High pressure builds over Western Canada and the Pacific Northwest starting Sunday. The ridge axis, that's the line of highest pressure, extends from Northern California up through British Columbia and into Alaska. This forces the jet stream to buckle. By Tuesday the 14th, the jet stream dives south over the Great Plains. Then it turns sharply northeast over the East Coast. That configuration is perfect for coastal storm development. The first area of low pressure develops over Texas Monday night, moves eastward along the Gulf Coast Tuesday. By Wednesday morning, it's near the Florida Panhandle, then it turns northeast. The GFS tracks this through central Georgia and South Carolina Wednesday afternoon. Snow develops on the northern and western side. The highest totals show up in the mountains of North Carolina and far southwestern Virginia. The model shows 8 to 14 inches for elevations above 3,000 feet. Lower elevations see 4 to 8 inches on this run. The coastal plain sees mostly rain with some mixing. That's the 14th-15th system, significant for the southern Appalachians, minor for the big cities on the coast. The 18th-19th system is different. Low pressure develops over Arkansas or Tennessee Friday night. This is a classic setup, cold air damming on the east side of the Appalachians. That's when cold air gets trapped against the mountains. You get an east to northeast flow at the surface, even as the upper level winds are from the west. This damming effect creates a zone of very cold air right along the I-95 corridor. Meanwhile, the low pressure system moves eastward. When it reaches the coast, it has cold air to work with. The GFS shows this low moving from the Tennessee Valley to the Carolina coast in about 12 hours. Then it rapidly intensifies. The central pressure drops from 1,008 millibars to 984 millibars as it moves from Cape Hatteras to just south of New York City. That is a pressure drop of 24 millibars in about 15 hours. Classic bomb cyclone. Snow breaks out Saturday evening from Virginia northward. By midnight, it's snowing heavily from Washington, D.C. through Philadelphia. By 6 a.m. Sunday, New York City is getting hit hard. By noon Sunday, Boston's turned. The snowfall rates on the GFS are impressive, 2 to 3 inches per hour for several hours. When you get rates that high, even a fast-moving storm produces significant totals. The GFS shows a swath of 12 to 20 inches from northern Virginia through southern New England. The heaviest amounts along the I-81 corridor in Pennsylvania and in interior southern New England. The European model tells a similar story, some differences in the details. The European tracks the 18th-19th storm about 50 miles further east. This keeps the heaviest snow more confined to eastern Pennsylvania, New Jersey, and New England. The I-95 corridor from D.C. to Philadelphia sees 8 to 14 inches instead of the higher amounts the GFS shows. Which model is right? Over the last several years, I've noticed the European tends to be better with coastal storm tracks 3 to 5 days out. The GFS sometimes over-amplifies storms at this range, but the GFS has also been right plenty of times. My approach is to look at both. The truth often ends up somewhere in between. The Canadian model, which doesn't get as much attention but is quite good, splits the difference. It shows the 18th-19th storm tracking between the GFS and European solutions. Snowfall totals in the 10 to 18-inch range for the I-95 corridor. All three models agree on the pattern. All three show significant snowfall for the eastern United States. The disagreement is in the exact amounts and locations. That's normal for this time range. Let's talk about temperatures in more detail. The GFS ensemble mean, that's all 50 ensemble members averaged together, shows a sustained cold pattern. Temperatures running 15 to 25 degrees below normal from January 15th through February 1st. For specific locations, here's what that means. Washington, D.C. Normal highs this time of year are 41 degrees. The ensemble mean shows highs in the mid-20s. Normal lows are 28 degrees. The ensemble shows lows in the low teens. Philadelphia? Normal highs 40 degrees, forecast highs low 20s, normal lows 26, forecast lows around 10 degrees. New York City, normal highs 39, forecast highs around 20, normal lows 27, forecast lows near 5 degrees. Boston, normal highs 36, forecast highs in the teens, normal lows 23, forecast lows near 0 or below. These are sustained temperatures, not just one cold day. We're talking about a week to 10 days of this. Wind chill becomes a serious concern. When you have temperatures in the teens and winds of 20 to 30 miles per hour, wind chills drop to 0 or below. Frostbite can occur in less than 30 minutes on exposed skin. If you work outside, this is dangerous. Take frequent warming breaks. Cover all exposed skin. Watch for signs of frostbite, numbness, tingling, white or grayish patches on skin. Now, region by region impacts. I'll be specific about what you should expect. The Deep South. You're on the edge of this pattern. The 14th-15th system brings rain and possible severe thunderstorms. The Storm Prediction Center will likely issue a severe weather outlook for parts of Louisiana, Mississippi, Alabama, and Georgia for Tuesday and Wednesday. After that, temperatures drop. But you're not dealing with prolonged cold like areas further north. Maybe a few mornings in the upper 20s or low 30s. Protect outdoor plants if you have them. Cover outdoor faucets. Your bigger concern is flooding from heavy rain, 2 to 4 inches likely. Some areas could see more if thunderstorms train over the same locations. The southern Appalachians and Carolinas. The 14th-15th system is your primary snow threat. If you're in the mountains, prepare for significant accumulations. 6 to 12 inches likely above 3,000 feet, possibly more in favored upslope areas. For the Piedmont, it depends on the exact track. The GFS solution gives you 4 to 8 inches. The European solution gives you 2 to 4 inches with mixing. Power outages are likely if we get heavy wet snow in the Piedmont. This time of year, temperatures hover right around freezing. Snow can be wet and heavy. That brings down trees and power lines. Have flashlights ready. Battery-powered radio. Food that doesn't require cooking. If you have a fireplace or wood stove, stock up on wood this weekend. The 18th-19th system likely stays north of you, but you'll feel the cold air that follows. Overnight lows in the teens. That is cold enough for pipes to freeze. Let faucets drip if you have exposed plumbing. Northern Virginia and the Mid-Atlantic. Saturday the 18th into Sunday the 19th is your event. High confidence in significant snowfall. Medium confidence in exact amounts. The range on the models is 8 to 20 inches. That is a wide range. But the low end of that range is still a significant storm. The high end is a major disruptive event. Start preparing now. Don't wait until Friday when everyone else is at the store. Get supplies this weekend or early next week. Bread and milk are not the answer. Get foods that don't require refrigeration or cooking. Canned goods, peanut butter, crackers, protein bars. Assume you might lose power for a day or two. Water is important. If you lose power, your well pump doesn't work. Fill bathtubs and large containers before the storm hits. For heating, have backup options. If you have a generator, test it this weekend. Make sure it runs. Check your fuel supply. Remember, generators go outside, 20 feet from the house minimum. Carbon monoxide kills. Travel will be extremely difficult Saturday night through Sunday. Airlines will cancel flights. Don't count on flying this weekend if you have plans. Roads will be impassable in many areas, even main roads. Even interstates. If you absolutely must travel, wait until Monday or Tuesday when roads are cleared. New England, both storm systems affect you. The 14th-15th system brings some snow, mainly to interior areas. The 18th-19th system is the big one. This has the potential to be a historic storm for parts of New England. The models show snowfall totals of 18 to 30 inches for interior sections. Coastal areas might see less due to mixing with rain at the onset, but still significant amounts. The wind is what makes this particularly dangerous for you. Coastal winds could gust to 70 miles per hour. That hurricane force. Combine that with heavy snow and you have whiteout conditions. Coastal flooding is also a concern. Storm surge could reach 2 to 4 feet during high tide. If you live on the coast, particularly north-facing shores, watch for coastal flood warnings from the National Weather Service. Power outages will be widespread. Trees will come down. In some areas, it might take several days to restore power. Prepare accordingly. If you have a wood stove or fireplace, make sure you have plenty of dry wood. If you heat with oil or propane, fill your tank now. Don't wait. The Ohio Valley and Tennessee Valley. You're west of the main action with these coastal storms. The 14th-15th system might clip western Kentucky and Tennessee with some accumulating snow. The models show 2 to 4 inches possible. The 18th-19th system misses you to the east. Your main impact is the cold air. Sustained below freezing temperatures for a week or more, that causes problems even without snow. Water pipes freeze. Car batteries die. Heating systems work harder and sometimes fail. Check your heating system now, change filters, make sure everything works. The last thing you want is for your furnace to quit during a cold snap. The Great Lakes and Upper Midwest. Lake effect snow is your story. When Arctic air moves over the relatively warm lake waters, you generate tremendous amounts of snow. The models show sustained northwest to north winds over the Great Lakes from the 20th through the 30th. That's a 10-day lake effect event. If you live in the traditional snowbelts, you know what this means. Multiple feet of snow, not all at once, but accumulating over many days. Snowfall rates might not be extreme at any given moment, maybe an inch or two per hour. But when it snows at that rate for 8 or 10 hours, then takes a break, then starts again, the totals add up quickly. Keep your driveway and walkways clear. Don't let it pile up. It's easier to remove 6 inches 3 times than 18 inches all at once. Some practical advice for everyone dealing with this pattern. Dress in layers. Synthetic materials or wool as a base layer, not cotton. Cotton absorbs moisture and makes you colder. A middle insulating layer, fleece or down. An outer windproof and waterproof shell. For your extremities, insulated boots rated for the temperatures you'll face. Insulated gloves or mittens. Mittens are warmer than gloves. A hat that covers your ears. You lose a lot of heat through your head. If you are reshoveling snow, use proper technique. Bend your knees, not your back. Push snow rather than lifting when possible. When you do lift, keep loads small. Take breaks every 15 to 20 minutes. Go inside, warm up, drink water. Yes, water. You can get dehydrated in cold weather too. If you feel chest pain, stop immediately. Seek medical help. Snow shoveling is one of the leading causes of heart attacks during winter storms. For driving, don't unless you absolutely have to. But if you must, keep an emergency kit in your car. Blankets, water, non-perishable food, flashlight, first aid kit, sand or cat litter for traction, small shovel, phone charger. Keep your gas tank at least half full. If you get stuck, you can run the engine for heat. If you do get stuck, stay with your vehicle. Run the engine for heat periodically. Make sure your exhaust pipe isn't blocked by snow. Crack a window for ventilation. Check on neighbors. Especially elderly neighbors or anyone living alone, a quick phone call could make a big difference. I want to hear from you. Leave a comment with your city and state. Tell me what you're seeing where you are. I read the comments and I pay attention to what's happening in different areas. If there's particular interest in your region, I'll provide more detailed coverage. Tomorrow's update will focus on the short term. That 14th, 15th system will have better model data by then. I'll break down exactly what the latest runs show. Sunday, I'll have a comprehensive look at the 18th, 19th storm. That's when the high-resolution models become useful. The NAM and HRRR models excel inside 72 hours. For official forecasts and warnings, always check weather.gov. Your local National Weather Service office, they issue the watches and warnings. What I provide here is analysis and context. They provide the official forecast. This pattern is real. The data supports it across multiple models and multiple timeframes. Prepare appropriately, stay informed, don't panic, but take this seriously.